No, I didn't lie. Let's keep it honest. I know, I'm sorry. Because I was going to make you write, like we were going to write something else, but I don't think you really need to write it. Sidebar. Is the deal. I hope there are some types of correlation. Yahi? That's not acceptable. Fix it. Okay? There are different types of correlation, but I think they're fairly obvious. If you had a bunch of dots that looked like that, anyone want to guess what you call that type of correlation? As you go from left to right? How about this? I'll give you the terms. Positive, negative, or no? Positive. Cool, groovy. Right, that's a positive correlation because as you look, right, if I were to draw a line of best fit, boom, they're generally going up. If I were to draw a line of best fit. Okay? That would be a positive. We don't need to put this in our notes. You can if you want to. Here, right, if I had something like this, why is it negative? Because generally speaking, right, you might have something like that's over here. It doesn't really matter. If I were to draw a line of best fit, it would be going down. It would have a negative slope. Okay? So if it's going up, or you have a positive slope, a positive line, it's a positive correlation. If they're going down, it's a negative slope, a negative line, a negative correlation. And of course, right, if you have just this, I don't know, right? There's really no correlation. There's just a bunch of random points. Can someone give me an example? Scratch that. All of you right now, I want you to take a minute to write an example for each situation. Give me two things, right? We're comparing, this would be comparing two things. Give me two things that generally, as you compare them, as one increases, the other increases. That would be a positive correlation. I'll give you a weak example. Generally speaking, the taller you are, the more you weigh. That's an example of a positive correlation. Is it always true everywhere? Do some people who are taller than me weigh less than me? Sure they do, right? There's exceptions, and that's what statistics is about. But generally speaking, the taller you are, the more you weigh. Okay? I want you to write examples for a positive correlation, something that as one increases, so does the other. A negative correlation, something that as one increases, the other decreases. And two things that have no relationship. There is no correlation. For example, no correlation. Your birthday and your shoe size. There is no correlation between your birthday and your shoe size. Okay? Yes, you can take that. What do you mean? So they also need to be something measurable, right? We're talking about like, if I talk about like favorite color and the temperature outside, like, they need to be two measurable things. So write three things. You're coming up with three examples that you are going to be sharing. You have 1 minute. Three things. Write them down. Yahi, do you need something? I'm just going to summarize these. The more you exercise, the longer you live. The longer your life. Yeah. What? What do you mean age and teeth? That doesn't...
Maybe from like
for a time, I'll agree with you that
you're a little kid because you weren't when you're super.
so right, like the older you get, the more teeth you have. And then you could argue that the graph of that would look something like this, right? When you're really young, I don't know. Right, when you're really young, yeah, as you're aging, you're getting more teeth. And then the amount of teeth in your life is pretty darn steady for quite some time. You might get your wisdom teeth, And then maybe it stays steady, or maybe you get old and you get dentures. I don't know. Okay. It would look so at times, interestingly, at times that graph would have a positive correlation, and you could also argue at times that graph would have a negative correlation. But yeah, for sure, the first part of your life that's happening. What else we got? Positive correlations. Yep.
The more kids that you have, the higher your insurance.
Okay. Mr. Rishu, what do you think? I don't have children. I just have you guys, which it feels about right. Okay. Don't have to say that. What else? What else we have? Arcane, you got something? Nothing. Great. Yeah, again, again, the graph of age and height would probably look something like the graph of age and teeth. Right? Generally speaking, you grow.
At around the age 35, you like.
And then
grow
sometimes,
60
like, you've seen, like, the slow, like, people seem to shrink. Posture goes down. Yeah. The more as your age increases, so does your height, especially in the early formative years. Anything else good? All right. What do we have for some negative correlation? Yeah, Xander.
I have the less food you eat, the lighter you weigh.
But as one's increasing, what's increasing right there?
Wait, oh.
Because as one increases, the other has to decrease.
Okay, I thought it was.
As one increases, the other has to decrease. Abraham?
The more junk you keep, the less space you have.
Oh, yeah, yeah. The more junk you have, not like junk food, but, you know, clutter around the house or random stuff, then the less space you have. Right? As you start collecting things or stuff gets messy, now you don't have any more space. Perfect. Yeah, the more cats you hoard, the less space you have. Yeah, perfect. Yeah.
More people who don't buy stuff at stores, the less money.
Okay, you kind of did like a double negative there, but I'll agree. The more people who don't buy stuff. So as you increase non-consumers, you're starting to lose money. Right? People who aren't buying stuff are going to make your company lose money. Right? Notice the difference here, right? As one's increasing, the other is decreasing. What could you say else? Oh, sure. If this turned into a time thing. Mm-hmm. How could I put this in the positive side? Cool. Yeah. The positive of that is that the more consumers, the more people consuming your product, right? And by consumption, we don't just mean eating, right? But like people who are buying goods, services. Awesome. What else do we have for negative correlations, Xander?
The more you sit around watching TV and not doing anything in your life, the less muscle mass.
The more you sit around, the less muscle. You are soft. Yeah, probably true. Probably true. Yeah.
More property,
Oh, maybe. Depends.
whether or not you
Depends what type of investments they are, right?
you're flipping
The-
the property.
If you have properties that are good investments and are making you money, maybe great. But if you have properties that aren't a return on investment and you're not getting any of your money, so. Okay. What about, yeah, Patrick, you have one?
Just generally, like insects like mosquitoes and whatnot, they in the past they have brought down so many like humans and like other animals, so because they can carry diseases.
More mosquitoes?
Yeah, like well, more insects that carry diseases, decrease of like animals.
Okay. Yeah. I agree. What about no correlation? Some things that are absolutely not related. This is gonna get crazy. Kane.
As his age gets older, Sam gets bigger shoes.
What? Whose age?
As his age
Ah.
gets older, Sam gets bigger shoes.
Right? Two people if I measure those two, they are absolutely not related. Jolie.
Would like the color of the car and the miles per hour?
Yep. Car color and miles per gallon. Not related. Ansel.
I have money earned and how many movies you've seen without Kevin Bacon.
Right. Income and movies.
Well, actually, wait.
They're probably connected, though. We all know that. You know, there's probably a degree there of separation. Yeah. Yahi.
Well, actually, no. Color and birthday.
Your favorite color?
Favorite color of your birthday?
No, just color and birthday.
What color? What? You can't. Like it has to be a. What are we talking about?
The color of your birthday cake is my birthday.
Yeah.
What? What? I don't know what he said.
Favorite color you gave.
Favorite color and birthday. What else?
I got one.
Xander than Patrick.
Let's see. The more baseball you play, the less carrots you eat.
Yeah, baseball and carrots. Nobody.
Actually, gives you better eyesight.
Yep.
Well, well, maybe. Patrick, what do you have?
The older you get, the more precipitation.
Yeah, your age and the rain. Not related.
Math and
Anthony.
math and
More apples you buy, more oranges or salt.
Yeah, apples and oranges. Yeah, yeah.
Ha 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 ha.
I'm not gonna write what you said. Yeah, yeah, Henry.
Light switches flipped to the amount of spaghetti you eat per week.
Yeah, how many times lights on and off?
Well,
And
what if
spaghetti.
You can't find the spaghetti because the lights are off?
I don't. How do you spell spaghetti? Well, here it is. Spaghetti. I got it. The H was coming in early. All right. So obviously we are good at recognizing things that have no correlation, right? If we were to find a weak spot, I think the hardest one for us to understand is when there's a negative correlation. And notice the difference between negative correlation and no correlation, not the same, right? No correlation, things that are absolutely not related. All right. So what we want to be able to do mathematically is be able to measure that strength of correlation. Okay? In order to measure the strength of correlation, you've already seen this before. There's something called the correlation coefficient. And it tells us, do things have a positive correlation? Do they have a negative correlation? Or do they have no correlation? So on your calculator, this is now what we really need to have in your notes. On your calculator, R is called the correlation coefficient. Really just meaning R tells you how strongly or weakly things are correlated. Do they have a correlation or do they not? Okay. Okay. 5 things, and then that's it. For one, first thing. Can anyone tell me what I just wrote?
A formula.
Also, you were up first. What do you got?
Well, I saw the greater than sign, and there's also the little minus underneath that. I'm not 100%
Okay.
certain.
Yahi?
It's -1 is equal to correlation. Equal is equal to 1.
It's not. Those aren't equal signs. Those are not equal signs. An equal sign looks like this, right? That's not an equal sign. What's that sign say right there? Not greater than or
Equal
equal
to or greater than.
Yeah.
Less than or equal to.
Less than or equal to.
Close enough.
Okay?
They said more
No.
than or equal
But it's important that we say less than or equal to.
to. But yeah.
Yeah, and it's important that we say less than or equal to. Okay? So really all this actually says, all this really says, give me a number that fits this, R. No. No.
5.
1, yes. What else? 0. What else?
12. 0.5.
0.5. What else? Negative 0.5. Negative 0.25. Really, all this says right here, this says R is between negative 1 and 1. R is going to be a decimal between negative 1 and 1. Could it be negative 1? Yeah, because it could be equal to negative 1. It could be to 1. It's like if I said choose a number from negative 1 to 1, right? That's what that means. R, that would be a boring game to play, but maybe we'll try that. R is between, you know, do you think it's impossible to guess if I say choose a number between 1 and 10?
No, it's 7.
Is that still impossible for you? See, there we go. For some reason, you know, we think full numbers. Okay. R is always going to be between negative 1 and 1. If you get that R is 1, I'll get there. I'll back up. Sorry. If you have that R is this, what did I just write?
Oh, so that's just a bullet point?
Yeah, the dots are bullet points. I'm sorry.
That was just part of it.
No, bullet points. What does this say?
One's being multiplied by negative.
R is greater than 0.
It's less than 0.
Greater than
Alligator eats the bigger one. Which is bigger, R or 0?
0 is bigger.
0 is bigger, so R is less than 0. What kind of number is that if it's less than 0?
It's a negative number.
Yeah. So if R is negative, right? Negative 0.5, negative 0.75.
Negative 99.
Not negative 16. It will never be negative 16. It will never be negative 16 because it cannot be more negative than negative 1.
I thought they were two different.
Nope, these are all connected. The same R.
So then, what do you mean? When, like, if negative 1 is greater, can you say negative 1, R, and then that sign, and then 1?
Less than or greater.
Less than or greater than 0.
You mean, like, could I put this, make that 0? This a 0?
Why did you say it has to be negative 1?
So this, here's the deal. R is always between negative 1 and 1. You will not get an R value that's 16. You will get either negative 1, negative 0.5, negative 0.25, 0, 0.25, 0.5, 1, right? It will always be in that range. There are some options, though, between there. If R is negative, right, if it's one of those negatives, negative 0.5, negative 0.25, negative 1, if it's negative, anyone want to guess, just if math made sense, what that would mean about the correlation? Yes. Thank you, Anthony. If R is negative, big surprise, there's a negative correlation. Look at that. If R is less than 0, if R is negative, if your correlation coefficient says like, hey, R is negative 0.5, that means it's a negative correlation. What's the next thing I'm going to write?
Positive.
Boom, right? If R is greater than 0, meaning if it comes out as positive, one of those positive decimals, 0.25, 0.3, 0.6, 1, if it's positive, there is going to be a positive correlation. Positive correlation. I told you we were writing 5 things. We've written 3.
We'll get to that, yeah.
Okay. What would, so here, right, negative 1 to 1, that's your range, that's your spectrum. What number would give you no correlation?
R is equal to
Say again, Abraham.
R is equal to
If R is 0, that's no correlation, right? If R is negative 1, negative correlation. 0 is no correlation. 1 is a positive correlation. And in fact, if you got R is equal to 1, right, that would mean it's a perfect line. It's a perfect correlation, right? Like the lines we have been used to working through. It wouldn't be a bunch of random dots. If R was 1, you would have a perfect
It would be
correlation.
whatever.
Okay. Now we are talking about the strength of correlation. So generally speaking, I'm going to write this and we'll talk about it. What did I just write?
R is more than 0.08.
Okay, so if R is more than 0.08, and I'm referring to negatives as well. So if you have R of 0.8, 0.9, 0.95, 0.97, the closer you are to 1, right, the more perfect, or the stronger it's going to be. That's going to be a strong correlation. So the closer you are to 1, the stronger that is to a positive correlation, right? The stronger, the closer the dots are to your trend line. And of course, the further we get away from 1, we get into there's no correlation, and then the dots start lining up to make negative correlations. So this is true the other direction as well. Like Anthony said, the closer to 1 you are, the stronger the positive correlation. If I'm closer to -1, what's happening? Right, it's a strong negative correlation, right? They're still tighter together. Now, there's a wiggle room, but we're just going to leave it like this. If R is less than 0.5, right? So 0.5, between 0.5 and 0.8, there's kind of a gray area. But if it's from 0.5 or lower, like 0.25, right, really close to 0, instead of a strong correlation, what is it? Weak. Right? It's a weak correlation, borderline. You could argue that there's no real correlation. The points are just kind of eh. Okay? So those are the 5 things we're talking about today. Now that we have this information, you guys essentially know, like, that's it for stats. Okay? We are going to do one quick problem right now, where you guys are going to make, most of these will be one problem. On your test, it's just going to be one problem. It'll look similar to this. You could call this a quiz if you wanted to. I'm not going to grade it like a quiz, but this is the types of questions that it would look like. Okay? So I'm just going to say, what I want you to do, is this. What I want you to do is this. That's good. Part shows me the scatter plot on my calculator. So you could always do that. Those steps right here on the bottom are to get a scatter plot on your calculator screen so you can kind of see the points.
Just get out the grab a calculator.
You have to define your variables. You got to tell me, Kate, you got to tell me what X and Y, you got to tell me what X and Y are, right? You got to say what they are. What do you have to do for representing and solving? It's kind of an easy one, I think. Solve. Can you guess and check? No.
You
Okay.
have to use
Um,
choose phrases or check the
What do you got to do for communicating reasoning? Xander.
Tell you how, you have to tell the person how you got your answer. Why answer.
Sure, how you got there, you have to show clear math steps. You have to get the problem right, accuracy. How do you reflect and evaluate? Big one. How do you reflect and evaluate? How do you check your work?
Yeah.
Both equations. Boom. Define your variables. Write some equations. Check both equations.
Or solve another way.
Or solve another way.
Yeah.
Beautiful. Okay,
But
great.
you can do that.
So,
Yeah.
full disclosure, this is going to be, you'll see this pretty similarly. Okay, I'm just telling you. I'm not supposed to tell you, but I am. This needs to be done by 10:50. That's 30 minutes. Yes?
Yeah.
Yes.
You can choose, like, I don't care. You can finish both of these. Some of you might in 30 minutes. This is our practice work sample. Tomorrow when you come in first thing, we're going to do the real deal.